All right, so the next section on 4.2 is called the graphs of inverses. So here's what you're going to be able to do when you're done listening to this video. Here's what you want to try to get out of it. Can you identify the graph of the inverse of a function given the original function? Secondly, can you identify the coordinates of the inverse of a function given the coordinates of the original? Thirdly, can you identify the result of flipping a graph over the y equals x line? That's very key. Fourthly, can you use a mapping diagram to determine whether the inverse of a given function is also a function? I kind of showed that to you in the last video. And can you apply the horizontal line test? Remember we had the vertical line test to tell if a function, if a equation was a function or not? Well, now we're going to use the horizontal line test to determine if the inverse is also a function. All right, so let's get started. We're going to start by reviewing. Remember how we found the inverse before. If we think about it, if the inverse undoes the work of another, the inverse of x plus 5 should be exactly x minus 5. So the steps that we kind of talked about last time was writing this as y equals x plus 5. The next step was to switch the x and y around, so write it as x equals y plus 5, and then solve for y. So we'd subtract 5, so we'd get x minus 5 equals y, and then we'd reverse to just say y equals x minus 5. It's the same thing. And then if we want to use the proper notation, if this is f of x, we say f inverse of x is equal to x minus 5. Okay, so that's how mathematically we would go through the steps to find the inverse. All right, so this section was called graphs of inverses. Well, let's look at the graph of these two. The first one, x plus 5. If you remember graphing, this is slope-intercept form, so 5 is the y-intercept. So if we go to 5, 1, 2, 3, 4, 5, that's my y-intercept. And my slope, remember y equals mx plus b? 1 is my slope, so up 1 over 1. So there's my first function. And then if we graph the inverse of that, our y-intercept is negative 5. 1, 2, 3, 4, 5. And the slope is 1. So these two functions are inverses of each other. And what I want to do is look at the two lines and see a relationship or how they compare to that pink line. So that pink line is kind of a special line. Does anyone know what the equation of that line is that goes through 0, 0, 1, 1, 2, 2, 3, 3? Exactly, it's the y equals x line. And so as you look at it, you can kind of see that if you fold the line, fold the graph over those lines, the blue and the red lines will meet up. They're the same distance away, they'll match up. Or we can say you can flip it, okay, they're symmetrical over that y equals x line. That's an important thing to know about inverse functions. Another thing that is going to come up in a minute, every point we just said in the last lesson, this is the point 0, 5. Notice then the reverse of that, the point 50 is right here. The point 50 is on the inverse. Notice this is the point 16 right here. That's the point 16. On the inverse is the point 61. So notice if they're inverse functions, then the input and output values are reversed. Kind of cool. And that works not only just for lines, but for if it's a quadratic equation that shapes a parabola, it'll always be flipped over that y equals x line, and the points you can always find the inverse by just flipping the points around. All right, so those are some of the key things in this unit. So again, let's use that technique of getting out your study guide for section 4.2. Go ahead and print it out if you're here at school, or if you're at home, you can again just take your own notebook out and take some notes here. But what happens when you graph the inverse of a function? We just did that. What happened? The graph is blank over the y equals x line. What word do you think we're looking for there or would fit? We're going to say flipped. The graph is flipped over the y equals x line. The x and y coordinates of each point are, remember I kind of showed you, we can say reversed. The point 0 became 0,5 and the point 1,6 became 6,1. The y values become the inputs now, or the input is the independent variable. And then the blank axis becomes the horizontal axis. Well, the x-axis was the horizontal, so they're looking for the y-axis. Now becomes the horizontal axis. And that's kind of explaining all this stuff here that we talked about. Okay. Then we talked about understanding that there's a test to see if the inverse is a function. From a graph. So if you remember when we talked just about functions, to tell if a regular graph was a function, we had a graph. If that's a function, we would do the vertical line test and look to see, is there ever a point where it crosses in more than one spot, then each input would have more than one output. So you do the vertical line test. So the purpose of the vertical line test is to tell if a graph is a function or not. How it works, if any vertical line intersects a graph at only one point, the graph represents a function. So we use a horizontal line test to tell if the inverse of this thing is a function. If the inverse is a function. And how does that work? If any horizontal line, I'm just going to help you remember vertical line. Let's draw the picture. There's a vertical line. If any horizontal line, which is sideways like the horizon, if any horizontal line intersects a function's graph at only one point, the inverse of that function is also a function. So we're going to look at the f of x equals x squared function. Okay? And here's the inverse, the square root. Okay, so we learned that if they're functions, then we can just flip the points. So here's a point, -2, 4. So on the inverse is 4, -2. Okay, if -1, 1 is on the function, then on the inverse is 1, -1. 0, 0, we're going to flip it, but you can see 0, 0 is not going to move. 1, 1 again, that's not going to. And then 2, 4 becomes 4, 2. Okay, so that's going to apply to the next page here where we've got a graph. This is x squared, so we want to graph the inverse, so we have to get those points. I know 0, 0 was one of them. 1, 1 was one of them. I'm going back to this down here. 0, 0, 1, 1, 4, 2. So let's graph 4, 2. 1, 2, 3, 4. 2 is here. Okay, and it's going to be a sideways parabola, so the other side will be, it'll be symmetrical here, the axis of symmetry. So 1, -1, and 4, -2 were the other points. So I just graphed the inverse of the blue by just flipping the points. And notice, if I fold it over that y equals x line, it's going to match up. It's flipped over that y equals x line. Okay, so we could do, so now we can look, is the inverse a function? Well, we could go ahead and do that vertical line test because now we actually drew it in there. But that past thing on your study guide right here, we talked about the vertical line test, but we can use the horizontal line test. So we don't have to graph the inverse to figure it out. In this case, we did. But if we didn't want to graph the inverse, we could just do the horizontal line test and say, hey, that hits in 2 spots. So the inverse is not a function. Is the inverse of the blue a function? We're going to say no, because we did the horizontal line test. And it intersected in more than one spot. And I actually did graph the inverse, so we actually could have done the vertical line test to say that, you know what, that inverse is not a function. But you do not have to graph the inverse to tell if the inverse is a function. You can just do the horizontal line test on the original. So this section 4.2 is pretty simple. That's basically what a lot of the quiz is on Apex, is looking at graphs and telling if the inverse is a function or not. So doing that horizontal line test. It's also knowing that the inverses are flipped over that y equals x line, understanding that the coordinates, if it's 0, 5, on the inverse it's 5, 0, that they're flipped. Okay. So here is an example on the checkup. You can print that out or you can follow along with me. We can practice a few of these. Is the inverse, all we want to know is the inverse of this a function? So we can do the horizontal line test. We can say yes, it only hits in one spot. Is the inverse of this a function? Do the horizontal line test. No, it hits in more than one spot. Number 3, is the inverse of this a function? Yes, everywhere you do the horizontal line test, it'll only hit in one spot. Is it here? It is here too, because everywhere you draw a horizontal line, it'll only hit in one spot. Okay, so you should be ready to go on and take quiz. There's some more examples you can look at if you'd like. You're ready to take the quiz on 4.2.3.